Introducing RC circuit. RC circuits. RC circuits is just simply the circuits that contain a resistors and a capacitors. So let's assume that, let's say that we have an AC source and then we have a resistors R and a capacitor C flowing through the circuit. So how RC circuit is behaving with this AC alternating current source right here. So previously our circuits just have the AC source and the capacitor C. Therefore, the only source of impedance, of restrictions to the flow of current, is coming from the internal impedance of the capacitors called capacitive reactance. Okay, so now your impedance in this AC circuits, impedance in this AC circuit is gonna be called Z, and it's actually the sum square of square root, because you gotta have your R. The impedance is now not simply the capacity of reactance from the previous case anymore, but it has the resistors and the capacitors. So therefore it's gonna be the two of them combined. So that's the formula that you should note it down. So impedance has the unit of ohms as well. Okay, so let's try example 24-8. So example 24-8, we have an AC generator with the RMS voltage. So our RMS voltage of 110 volts is connected in series with a resistor of value 35 ohms and a capacitor 11.11 microfarad. The RMS current is 1.2 amps. Part 8. What is the impedance? And we knowing that this source of impedance coming from both resistors and capacitor. And B, what is the capacitive reactance of this circuit? C, what is the frequency of the generator? 12 hertz, right? Okay, so let's draw our circuit down. The source of voltage, your resistors, and your capacitor right here. Okay, so part A, to find the resistance or impedance in general, right? We use the same formula, the Ohm's law formula. So from Ohm's law, we have V equal to IR. But knowing that this is an RC circuit, so the impedance is not only coming from the resistor itself, but it's also coming from the capacitors. So this R should be replaced by Z. So with the given VRMS and given IRMS, multiply by that by Z. And Z is part A. Z, the impedance will be VRMS divided by IRMS. VRMS is 110 volts divided by 1.2 amperes, and that give you 92 ohms. So that's the total impedance coming from the capacitors and the reactors, resistor as well. Okay, part B. So what is going to be your capacitive reactance? Capacitive reactance, which is the impedance coming from the capacitor itself. From our equation, we got this, right? Because total impedance would be equal to the resistance plus capacitive reactance, or Z square is R square plus C XC square. Therefore your XC is gonna be Z square minus R square, and then we do the square root. Z is 92 square, 92 ohms square minus your R 35 ohms altogether square root. XC gonna be 85 ohms. So we can see that majority of the impedance for this circuit is coming from the capacitors. Okay, part C. Part C is what is the frequency, to find the frequency of this circuit, right? The frequency at which the generator is generating is alternating current. So we know X of C, knowing that X of C equal to angular frequency multiplied by capacitance, and omega is 2 pi f multiplied by capacitance. So to find f, we have to isolate f. So f gonna be 1 over 2 pi c xc. Just simply switch their position right there. So your f would be 1 over 2 pi. Your c is 11 microfarad. 11 times 10 to the -6 microfarad. So -6 farad multiplied by X of C, which is 85 ohms that we found earlier. For you got your frequency of 170 hertz. And that's it for this example with the AC circuit concepts. Basically, it just have resistors and capacitors and the AC source. It can be either AC or DC, but now we're learning about the AC source. So that's how it is. The impedance gonna be the sum of these two.